Hi everybody, today we are continuing in our unit of trigonometry and learning about something called the ambiguous case. So we already know how to use the sine law and the cosine law when we're dealing with acute triangles, but there is one special situation where you actually don't have enough information to solve just one triangle, and that's something called the ambiguous case. So if you've heard the word ambiguous before, you might know it means that it could go one way or another. There's not enough information to make it clear. So that's the case with one certain kind of triangle. So in this type of triangle, you're always going to be given one angle length, then a side next to that angle, and then a side opposite from the given angle. Okay, so really you're given an angle, a side, and a side. You can take that acronym angle, side, side, and see that it spells a very bad word. So anytime you know that that bad word is being spelled, angle, side, side, then you know that you have a potential ambiguous case. So what happens is that you're given an angle, like, okay, there's 40 degrees, and then the side length next to it is 22 centimeters. And then you're given the a second side length. Let's say that it's the length of this marker here. Okay, you're not given the length of this, you just know that it makes a 40-degree angle with this line, but you don't know how long it is. But you do know the line is this long, so it would be natural to say, okay, well I take this, and then I just connect it with this line, and that makes a triangle, a nice acute triangle. So Mrs. Weens, what's the deal? Like, I know that this is 27 long, and this is 22, and then this is 40, so I have a known ratio. I can just use sine law to figure everything else out. But watch what happens when I do this. The length of this marker is such that if I turn it in this way, that would make another triangle, an obtuse triangle. So there wasn't enough information to tell you whether this length should make this size of triangle or if it should be making this type of triangle. So that's the ambiguous case. There's actually two possible triangles in that given situation. So that's what we're going to discuss today, how you recognize when it is the ambiguous case and what you do when that does happen. All right. So most of the time when you are given three pieces of information regarding a triangle, it represents a unique triangle that you were able to solve using the sine law or the cosine law. However, there is one case where two triangles may be possible. When you are given angle, side, side, in that order, further investigation is required. So it has to be an angle, an adjacent side, and the opposite side for this to be the case. So, in this case, let's label this diagram, okay? This here, we'll label it as angle A. So that's given. And we'll label B, little b here. And then we don't know the length of, and we're given the length of this, however long it is, which is little a. So think, we know that this is little a because it's across from big A, so that's how it will be labeled. So we are given A, the possibilities, which we'll discuss in a minute, the possibilities depend on its length, okay? So the different situations that come about depend on the length of A that is given. This here is the height of the triangle, okay? So remember, the height of a triangle is always, it always intersects at a right angle, the base at a right angle. So this length is, and then this length here, this length here is an unknown side length. Okay? So we are given, again, in the question, we're going to be given the size of this angle. Oh, this marker's dead. Sorry. We're going to be given the size of this angle A, the length of B, and the length of A. So it could hit all the way, it could be too short, it could make a right triangle. We don't know. That's what we're given. And then we do more work to find out how to actually draw this triangle. Okay? But remember, this h is the height of the triangle. It has to meet at a perpendicular. Okay? So, again here, note that the height, h, can be represented by something special. So, think about it. Sine A, the sine of A is opposite over hypotenuse. So opposite is the height, and the hypotenuse is B. Okay? If you're looking at this right triangle, this possible right triangle, then you can use SOHCAHTOA. So therefore, if you rearrange this, H is just equal to B times sine A. So it can be represented by B sine A because of this. Okay, now this is a very important conclusion. The fact that if this is a right angled triangle, then this height here is represented by B sine A. And remember, we're going to be given the length of B and the size of angle A. So that is going to be something that really helps us. So you need to understand this situation here and why the height is equal to B sine A. So take a moment to study that. And if you don't understand it, then make an asterisk to make sure you ask me, because that's something that's very important that you understand. Okay, it's just using SOHCAHTOA. So rewind the video if you need to see that explanation again. Okay, so here we go with our cases. Case 1, there is no triangle possible. So in case 1, we're given A, the angle A. We're given this side length B, but the length of A that we're given, little a, okay, is less than B sine A. So what that means is that this length of A is less than the height of the triangle. And if that's true, then that's not even possible. You can't create a triangle like that. So in this case, there's no triangle possible. You cannot create a triangle because A is too short in comparison to angle A and side length B. Okay? Given that this is H. So really this is saying A is less than H, but you're not given H. You're given B sine A. So you're using B sine A to find H. So really that's what you're finding. Okay? Now, if, again, you're given angle A, side length B, and your A here is equal to the height, then that gives you one right triangle. So that is if the A that you're given, the A that's the side length, is equal to B sine A, and again, you're given B, and you're given the angle A, so you can find that. And if that's equal to the side length A you're given, then you can actually reason, oh, then that must be a right triangle because of this equality, okay? So far, neither of these cases is ambiguous, okay? In both of these cases, you either can tell for sure that there's no triangle or one right triangle. You just have to do a little bit of work to figure out which situation it is. But now we get to another point where there's just one possibility. Okay, case 3, there might just be one obtuse triangle. So an obtuse triangle occurs if you have angle, again, you're given that angle A, you're given the side length B, and if your A is greater than B, so the side length here is some long angle, okay, this is your A, and it's longer than this B, then that will just create one obtuse triangle. So A is long here, so A is longer than B. That creates an obtuse triangle because this angle then is obtuse. All right? But we get to the case now where what if A is bigger than the height So it's longer than the height, but smaller than B. Okay? So what if the length of A is longer than this height and smaller than B? That's when you get that two triangles are possible. Okay? So when A is less than B, but greater than B sine A. So really that's saying larger than the height of the triangle, but smaller than the side length B. Okay, that creates, so you can say A, so the side length A can swing to two locations. So if you imagine that side length, it can be either here, or you can swing it, that same length, to be here, like I was swinging the marker before. So either it can be here, or that side length could be here. So, you can draw it. I'll use a different color. So use a ruler, and then here's your side length B, or sorry, your side length A, but it could also be drawn here. Okay, so this would be your possibility A1, and this is your possibility A2. Now, this creates, these are both the same because they're the same line, just drawn in two different places. Okay, so this is your first possibility for the angle length of B, given that this is angle A and this is side length B. And this here is your second option. So this is B1, and this is your second option for how big angle B can be, right there, B1. Okay, now note that you also have two different options for C. Okay, C is either this size right here, or it's this size right here. Okay, depending on if you're looking at triangle A to B1, sorry, A to C1 to B1, or A to C2 to B1. Okay, that will change. Something else though you have to note, that because this triangle, which we don't really consider here, is an isosceles triangle. Oh, sorry, that should be labeled B2. Okay, these two angles are equal. Okay, and because this creates a straight line, that concludes, since this is as big as B1, that B1 plus B2 have to equal 180 degrees. Okay, so again, the length of A is the same regardless, but A could be in this location or this location. So A1 and A2, they're the same length, it's just, is it placed here or is it placed here? So because of that, you could have angle B being an acute angle here, or you could have angle B being an obtuse angle if it's placed here. But to help you figure out what B2 is, once you've found B1, you need to use this fact that B1 and B2 are supplementary. They add to 180. Because B1 would also be the same length here, the same size here, sorry, and this just creates a straight line. So this would be B2 plus B1. They have to sum to 180. All right, so we will be coming up with an example later on where this actually does happen. But for now, you really need to take a good look at this and make sure you understand all the labeling that happened there. Okay, so if this is the case, then you would solve for, first of all, triangle A, B1, C1, and then triangle A, B2, C2. All right, so you have to solve separately for two triangles because you weren't given enough information to make a unique triangle. Either one of these triangles is possible. All right. Now, all of those situations relate to if angle A, the angle you're given, is actually an acute angle. But there's also two other options for if your angle that you were given is obtuse. So if angle A is greater than 90 degrees. So here's angle A. This is side length B, and this is the unknown length C. Okay? So if A is less than or equal to B, there's no triangle. Okay? So A is too short to actually complete and ever touch this third side length because you are given this angle, so you know it has to be that big. But A isn't long enough since it has to start over there at B. That's no good. But if A is greater than B, then you just create one triangle. So again, you're given this angle A, you're given the side length B, and the side length A. And then where it touches here will give you, you'll be able to find side length C, angle B, and angle C using the sine law. All right, so if all of that is super confusing, hopefully